working. What's saying it's not working? Bsoft Collective. Oh, that's because it's gone. Oh, that's all that's at. That's all that's saying. Okay, never mind. All right, so we are here. We're going. I started a little bit late. Got into a discussion with someone and was kind of hoping to do some things, but did not get to. We're going to see how many people show up. Let's get the chat open. Yeah, actually, we are going to go ahead. Let me get some. Let me do this real quick. While we're waiting for everyone, we'll go to Bsoft Components. That'll help us. Actually, we might even go into some other things, but we'll teach from here. We'll teach from here. We'll show some things. That's what we'll start doing. Stupid thing. I'll take it off my things here. Tired of seeing that here. I can't. Oh well. It's not a big deal. So we're getting started. We're getting going. We need to hurry because I have a space starting at 2:45. So if people show, they show. If they don't, they don't. Like I said, since no one's here, I get a feeling this is going to be my last stream. This seems to be a pretty common occurrence where I don't get much for people showing up. So I've been talking a lot about 3D Interactive, and honestly, I feel that if no one wants to show up for these things, no one wants to see what I'm doing, there's really not much point in doing it. But I did say I was going to do this one, so I will do this one, and then we will move on from there. Okay, we got one person. We got to go. I got a 2:45 space to start. I'm going to start on my phone, so we're going to get going. I'm going to go ahead and do a screen share. It's going to be, we'll screen share Bsoft Components. So we said today we were going to talk about the basics of software development. So what we will do here, this has a nice little feature that I can kind of just throw into a Scratch file. It'll ask me what I want my Scratch file to be. We're going to want it to be TypeScript. So we will open up the TypeScript file and we'll start with this. This will be our just sort of Scratch location and all that kind of stuff, where we can start to talk about things. So the basics of TypeScript, the basics of JavaScript, the basics of software development. Where do we start? The most basic part of any software application is the variable. The variable is used for a lot of things. The variable is used to, but it's basically used to store information, store some kind of information. Here we'll start with a very simple test. In TypeScript, you can give a variable a type. You can actually tell it that it is a particular type. So you put a colon and you say this type is going to be number. I can do that. And there I've declared a number variable, and that is a number variable. However, TypeScript also has the ability to infer types. It sort of works in the way that JavaScript does. So instead of saying number, what I could do is I could say 0. And if I say 0, test is now, TypeScript's been doing this lately. It's something that if you do something like this here, maybe I can say 0.5. What if I do that? Will it say it's a number, or will it type it as 0.5? And I never understood why they started doing this. TypeScript recently started doing this. It used to be if you assigned it directly to a number, then it would take it as a number. It would say it's a number. Now it types it as the actual type you assigned it to, unless you do something like a string. So in the case of a number, it'll do this. In the case of a string, I think if I were to do test, oopsie, maybe I'm wrong. Maybe it's still doing that. So yeah, it's expecting it to be test basically. They've started doing this recently. So if you don't want that to be the case, you can say string, and it'll allow you to assign test to string. If it's a number, you can give it number. Let's see if it'll let me just kind of put them all out here. So here you got string, Boolean. Void is usually a return type from like a function. If a function doesn't return something, it's a void type. Unknown is the type that's preferred nowadays to any. Basically, you have any types, which any types allow basically anything to happen. Here's a very, very, very important point of TypeScript recently, especially since unknown was created. It used to be that you either had a type, string, Boolean, number, or you had, you'll see it right down here, any. I don't know when. I think it was in the fours, somewhere in the four releases. They came out with this concept of a type called unknown. Unknown and any work very similar. Any basically says it can be of any type whatsoever. There's positives to that, in that basically what that is, the any type in TypeScript is almost like a JavaScript variable at that point. It's the same thing. It's the same thing that JavaScript does. When you assign it something, it types it based upon whatever's assigned to it. It types it at runtime as to whatever is assigned to it. And that's how any works. Any lets you do anything you want to with that variable. Unknown is different. It does allow any type to be assigned to it. However, before you use that type in TypeScript, you have to do one of a couple things. You either have to give it a type, you have to say as. So if you were to say here, if we were to say unknown and we were to say test, before we could use it, if I were to try to say test dot, you're going to notice that it comes up with nothing. It comes up with nothing because it's not known. So if I want to say what it is, what I would say test as string dot, and there we go. Now we've got at lowercase char. We've got all of the different string functions that are available to string because we typed it. There are other ways of doing this too. It's not just typing, but let's not go into that right now. That's more advanced topics. There are things referred to as, I'm gonna have to remember what they're called. I've got a couple of them over here, and I'll remember them as soon as I see them. That's kind of one. A type assertion, I think, is what it's called. That's right. I believe it's called a type assertion. It's something like this. It's basically proving or trying to prove that it is of a particular type. But like I said, that's more of an advanced topic. What I just showed you there is probably is an easier way to deal with unknowns. You have to give them a type before you can access them. If you try to just say, well, I know this is a string, so therefore I'm going to use a string method, TypeScript won't allow you to do it. It'll actually tell you, you need to give this as a type before you use any of the functions that are available on that type. So it will not let you work with it unless you give it a type. So that's really the positive of using unknown from the standpoint of someone like myself, who maybe is sending out data as unknown, but I want to make sure that users of my function, users of my component, users of any of this stuff are doing what they need to before they actually use it. So I'm not allowing them to have bad programming practices and things of that nature. So they have to type it. So I know if I use unknown, I know that they have to type it before they're allowed to do anything with it. So let's see if we can go back to here and I can go through the rest of these here. Let's just say, there we go. Okay, unknown number. Object is just JavaScript's object Boolean, which we all know, true, false, things of that nature. Yeah, undefined is just you can give it a value, give it no value. Basically, it's like saying it doesn't have a value. The value is undefined. You usually have to give it a type and allow it to be undefined. There's two ways of doing that. If you're defining it inside of like an interface, you can put a question mark on the property, and that will say that property is allowed to be undefined. Usually, if you're declaring a variable like we're doing here, you actually have to do like a union type. One of my examples in one of my posts about this showed a piece of code, and it said, I think it was string or undefined. That's how you would have to do it. That's called a union type, by the way. So you can actually have multiple different types. Also, big int got brought into JavaScript recently. There's a number, and now there's a big int, which holds bigger numbers basically. Let's see here. Never, I don't use never much, but never and unknown are very similar. I forget how never is different because I haven't used it all that much. These are just other pieces. These aren't actual symbol. Okay, symbol is technically a type, but trust me, you're never going to use it. In all my years of JavaScript, I think I've dealt with symbols once or twice, and that's it. They're kind of a more, advanced topic, probably beyond what we should be talking about here. That's pretty much it. Those are the basic types. And then you can actually give it any type that you've created as well. So if we look at something like the interfaces here, any of these, any things that say interface, these are all types. And here's the example I was talking where I said you can put a question mark and it can be undefined. That's a very good example right there of how you can, of how when you're creating an interface, when you're creating a type of some kind, which usually we use interface when we're doing types like this. You can put a question mark for a property, and that says this property is allowed to be undefined. So in this interface here, let's use as an example, these 5 right here are required. If you're going to create a BSoft theme type, you have to pass these, at least these 5 variables. Now the rest of these are all allowed to be there, but they're also allowed to be empty, so or to not be defined. So that's what that means. When that says undefined, what that also means is that you don't have to pass it for this to be considered a valid type or a valid object of that type. There's a better way of saying that. So that's what I mean when I say about things being undefined or being able to define things as undefined. If you look at this, it is string. I hope you can see this. It might be a little small. It is string or undefined. So the question mark there allows it to be undefined without having to have the or undefined at the end of this. It does that for us. It's a shortcut key basically to doing that. You can do that inside of objects as well when you're declaring actual private properties or private variables inside of objects. You can also put question marks in there as well. But when you do a general declaration like you're doing over here, you usually can't put question mark. I don't know, can you? I don't think you can. Yeah, you can't. So you can't put question mark there. So you quite literally have to, you'd have to. See, it throws an error, so you can't. So basically, you have to put it in the type if you want to define it as a type. Let's see what we got here. Okay, yeah. All right, so let's move forward. So that's variables. That's variables, typings, the way we can assign them and things of that nature. This is mostly JavaScript, even though yes, we're using TypeScript, and I'm showing you how to use types. Most of what you're seeing here, minus the whole type part where I put this and I started talking about types, everything else here is all JavaScript. Even the const. Const is now, I don't know when it came into the language, but const and let are now the ways of declaring variables. I think you can still declare var. You'll probably still be allowed to do it in JavaScript, but it's not really considered best usage. The reason is this. Here's the difference between const and let. Let is the way that JavaScript used to declare variables. So when you declare a var, it's a let. Let says that you can assign to this variable and you can reassign to this variable. So basically you can assign to this variable. For example, if I were to declare this a let and I weren't to give it a type, actually TypeScript wouldn't let me do this, but JavaScript would. Here, I've tried this before and it actually will fail. Trust me, this will fail, but in JavaScript, this will work. So it's saying let and it's string. And then I come over here and I say test is equal to, it'll actually throw an error. But that's a TypeScript error. In JavaScript, I could do this with a let. So it says, oh, type number is not assignable to type string. But what is happening here? It's right there. It's a TypeScript error. You can see it right there, TS2322. It's a TypeScript that's throwing us the error. If this was just plain JavaScript, it'd let us do this just fine, because JavaScript doesn't worry about what the type is at design time. It worries about it at runtime. And even at runtime, this is still a valid statement in JavaScript. You can still do this. But lets us reassign it. So if we want to give an example, we could say test2, and there we go. There we are. All right. So that's good. It allows us to reassign it. Now, if we come in here and we say const, on the other hand, the reassignment fails. Why does the reassignment fail? Because const only allows you to set the variable one time, and then that's it. So if you're only going to hold a value in a variable and never really reuse it anywhere else, declare it as a const. My IDE and my ESLint settings that I have check for this stuff. So if you declare a variable as a let and then you never reassign it, it will actually throw a TypeScript error, and it will tell me, oh, well, you can't do this because you shouldn't be using let and you should be using const. Why should you use const over let? You should use const over let because it's smaller in the way of the amount of data it takes up to store that item. If you don't have to reassign it, you can use a const, and a const is a smaller variable. Now, yes, I know we're talking about probably not a whole lot of things, but you got to think about it at a larger level. Imagine you're writing, a piece of code that declares this variable and declares this variable over and over and over and over and over and over and over again, 10, 20, 30,000 times. That small little bit that didn't seem like a lot can now become something that's very, very huge, if you get my drift. So any savings we can have, we need to think this through. And that's why I use certain ESLint settings in all my projects, because it'll catch them for me and say, you should really declare that let as a constant. It never gets reassigned. I'm like, oh, because it'll catch things from me. Because sometimes I think I'm going to reassign it. And actually in my IDE, since what it does is it picks up the ESLint settings and it will alert me right away. So it won't even let me do it. If I declare it a let and I haven't redefined it yet, that error will be there until I actually reassign it. And then it'll go, oh, okay, you did reassign it. But it will sit there and bother me until I do. So usually I declare things as constants until I realize I'm going to need to reassign it. And then I pop back over and I declare it as a let, because once you try to reassign it, it'll give you an error anyways, and you go back and change it. So that's all that is. That's all there is to that. No chats yet. No questions. If anyone's got questions, this is supposed to be a beginner thing. I really would like to see what you guys have to say. I really would like to know any questions you have. We are going to try to finish this up here in 30 minutes, so I need to get moving. Next thing. Okay, so I'll discuss now the actual thing I put in the post. It's referred to as a ternary condition. We have logic. Logic conditions are a big part of software. You have something stored in a variable. Usually you're always checking a value of some kind in a conditional. You're always checking that something is something. It's always some kind of, it ends up being some kind of Boolean condition. The condition has to equate to something that is a true or false, because that's how conditionals work. What we could do is let's do this. So let's do const value, and then you say, if we were to say test is equal to test, then put, okay, fine. Yeah, sure. Now, here's a really good point as well. This actually is really good. So here is the ternary operation. So the ternary operation, I hope I'm saying that right. My brain's not fully functional right now. I just had my coffee. So the ternary operation says, if this conditional is true, then we will return the true condition. So the true condition is the first condition. If the ternary condition is false, then it will be false. Then we'll assign false. Now, my IDE here is giving me a warning. So it's giving me a warning saying that, so basically here is a Boolean. This is a Boolean value. It's either true or false, but we don't have to do this, especially since we're returning true or false. If we were returning something else, if we were returning another string, if we return something like this, we said is test, and then over here we would say not is test, which I hate that it does it. It should just put it as a string. It's now created this. It's now defaulted this to a union type. See, this is what TypeScript is doing and things like that. Anyways, it's kind of annoying because now you've got to say, oh, instead of saying it's a string, but whatever. This is where in this case, if you don't want it to be the union type that's being assigned by TypeScript, you can tell it's a string. But this is another way a ternary operation works. So one would assume that test wasn't just declared like this, it was declared somewhere else, and somehow it was going to get some kind of potential value. One value would be test and other values may not be test. And then you would either store the value of is test or not is test based upon the conditional here. So the conditional here, if it's true, will house this. If it's not true, will house that. So this is for very simple logic operations. When you have one thing that you need to test, and that's all you need to do is test this thing, and if it's not this thing, you do this over here, then you might as well use a ternary operator. It's simple, it's small, you can run it in a single line. It's very basic, it's valid code. So it's an easy way to do just a single test and have an if else. If this, then do this. If not, and it's also useful when you have one single thing that happens. If you have these big, huge logic blocks, obviously you don't want to use the ternary operator; it'll look nasty. But you want to use an actual if then else and all that stuff, which we will discuss here in just a minute. But let's go back to the example we had where we had true or false. Now, why was it saying the problem here with true or false? The error I was getting here is it was saying that this can be simplified. Test true or false can be simplified to just this. And that's a Boolean. So in the case where we want to only return a Boolean value on a test, we can just perform the test itself. We can just perform the actual test itself, and then it will store a Boolean value. So if it's test, we'll get true. If it's not test, we'll get false. So we don't have to use the ternary operator. We can just run the condition itself, especially very simple conditions like this. We can just run the condition itself and store the value. This is also how conditional logic, how if then else logic and things of that nature work. Let's set up something, because that's what I'm going to talk about next. So we've got test 2. What in the world happened there? Oh, well, here. I will go back and up my display again. I hit a display button here. Okay, so test 2 is equal to test 2. Simple examples and things like that. We're going to get rid of this because that was just showing how we can store the value of a conditional, how we can store different values based upon conditionals. But like I said, sometimes we may have more complicated logic that we have to do. Now we can do one of many different things. The first one I'm going to show is the if else, and then I'll branch it to an if then else, and you'll see what the differences are. Let's see here. Okay. No questions so far. So, all right. So what do we do? So we will say if we can do a number of different things. So let's recreate the ternary condition, but let's recreate it in an if structure here. So we will say if test is equal to test. And this thing will actually give me here. We'll say some logic. We just need to have something in there, or else it'll warn me about having an empty. And then you say else, and you say some other logic. So that's what would happen here. So basically, if we needed more complex logic, this is the more complex structure of what we just showed previously. Since we aren't just storing a Boolean, or since we aren't just storing a simple value, but we might have many different pieces of code we wish to run based upon each one, then we might end up going in. This is the way we might end up going to make this work. Now we can, and we could have done this with the ternary operator as well. You can have multiple conditions in a ternary operator, but I'm just going to show it here as well. So we could also say this, and test 2 is equal to test 2. Same kind of thing. So now both of those have to be true for the if to be run. If both of these conditions are not met, so if test has test, but test 2 has something else, it will fall to the else. So both of these must be true for this to be run. If not, it will run over to here. Now, there was something else. Oh, yes, that's what I was going to bring up. So you'll notice here, in most programming languages, you will see, hang on here, that as the equals condition. And it works valid in JavaScript as well. This is a valid condition. So why do I use the triple equals? And I brought this up before in many posts, but I'm not sure how many people have seen them. So here is the answer to this. The double equals in JavaScript, before it does a comparison, it attempts to make sure that both sides are equal. So if test was a number 2, for example, and our conditional over here, instead of being test, was a string 2, and we had a double equals, it would attempt to convert them. I believe what it would do is it would convert the left-hand side to a string. So it would convert the number 2 to a string 2 and then do the comparison. So it would actually do the conversion first. So why don't we just use that all the time? Well, it's an extra step. It's an extra step. So if you know that that your variable here should always be a string, and if it's not a string, then you don't want it. Then you don't want it converted anyways. You want it to go ahead and do the comparison as a string and fail when it's something else besides a string. Then you can go ahead and use the triple equals. The triple equals just does the comparison without the attempted conversion. So it saves compute cycles. Once again, here we're talking again. This is yet another one of those things where it doesn't seem like a very big deal until that code is run 10,000 times, 20,000 times. And now those little itty bitty microseconds that you didn't think was a big deal now suddenly becomes a very big deal because now things are running a lot slower than they should. It's always about performance, especially with me. I'm going to, if I see someone use a double equals and something like that, I almost always peg that on a PR and say, use the triple equals. Is there a reason? For the first question I have is there a reason you're using the double equals? And if there isn't a reason that you're using the double equals, if you can't validate a reason to actually use the double equals, in other words, telling me that you know what the double equals does, then use the triple equals. So I almost always use triple equals unless I know for a fact that it's possible that the variable may have different types in it, and I do want that type conversion to happen. There are times where I have used double equals, but it's very rare. If you look through most of my code, you'll see triple equals. All right, no questions yet. All right, so that's very simple logic. We also have if then else logic as well. So what I'll do is I'll cut this one out so we can do this. And then what we'll do is we'll probably just do it like this. Oops, no, that's not what I wanted. I wanted this, and then we'll say else. It's going to make me type it like that. Okay, else if, bam, 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 bam. There we go. And then we'll say some more logic. And this is now what's referred to as an if then else. So you have if. So now we're testing that test one, that test is test. So if test isn't test, then we're going to look at test two and see if test two is test two. If neither of these conditions are true, then the bottom one is run. So a lot of times that's what you'll see. You'll see a lot of logic like this, and you can put as many else ifs as you want to in there. You have to think through your logic, though. You have to think through, is there a reason that I need to check each one of these, and which one should I be checking first? Because if test is test, then you're going to run the logic inside of here. If you're expecting that this logic be run when test two is test two, then you need to make sure that there's possibly another check. So instead of, this is in the situation where you're saying, if this variable is this, then we want to run this. A secondary possibility is if this variable is this, and then we'll go ahead and we'll run this. If not, we'll run this. If it's important that when test two is run or is test two, that logic always be run when test two is test two. And if it's important that when test is test, that logic is run when it's test, then you would want to do something more along the lines of potentially this. Why did we do that? If test two, let's see here, is equal to test two. Now, if we only wanted that to run, we could leave it there. We could also throw an if at the end of this as well to say if test two isn't test two, then do something else. So we could easily throw another else onto there and have our final condition here. So we'd have a final condition here. So that's, like I said, you have to understand, you have to start thinking about all of the different things that are coming to play. This is very simple. What I'm showing here is extremely simple. And it's a simplification of things that get much more complicated much more quickly. This is basic conditional logic. A lot of times what you'll have is you'll have this more than likely, instead of having it like this, what you'll have instead is you'll have it inside of a function. So you have function my function, test one as a string and test two as a string. And then you might have logic like this inside of the function. Actually, you'll see something here. I'm going to leave this for just a second, because I think this is pretty interesting and pretty important, a pretty important thing to understand about JavaScript. So we've got my function here, and my function is a function that we can call down below here, actually even above here, because since we use the function type, we can actually call this from anywhere. There's a concept in JavaScript referred to as hoisting. If you use the function keyword in JavaScript, I could technically say my function and call it up here. That's function hoisting. That's referred to as hoisting. Here's the difference between hoisting and doing a const declared function. Now, there's another. There are many ways to declare functions in JavaScript nowadays. Another way, you'll see me do this in all of my components, but there's a reason that it's okay in my components, because basically you're never gonna have to worry about hoisting. But in a situation like this where you're worried about hoisting, if you were to say this is another way of declaring a function. You'll notice that my function still exists, and it still exists as a callable function. Look at that, it's a function, and it returns a void. But up here, I cannot call it, because now this since it didn't use the function keyword, this is now a const declared function. It's a scoped function, so we are calling it before it's declared. In the previous one, since we used the function keyword, it was hoisted up to where it was callable from anywhere. But since we no longer are doing that, since we're now declaring it as a const, we have to do this. Now it works, but it works because because we declared it this way, we have to declare it before it's used. So definitely think about these things when you're starting to use them and when you're writing things. You know, function, if it's something that you're going to want it to be called from anywhere, and you're not going to want to have to sit there and think about where this is declared and this and this and this and all that kind of stuff, then it's very important to declare it the right way. We'll leave it as const declared now, and we'll still talk about this part here. If you notice, this isn't throwing an error. Why isn't this throwing an error? It's test1. I changed the name here to test1, but I'm not using test1. Actually, it is throwing an error here saying it's never used, but that's beside the point. Yeah, still no questions. So why, oh why, is this not throwing an error? Well, this isn't throwing an error because it's declared outside, but JavaScript has the concept of something called scoping. So this function is declared here. This variable is declared here, but this variable is declared in a scope that my function exists within. So therefore, I can take a variable from the outside and use it from the inside. There's a lot of very interesting, not just interesting, but also problematic things that can possibly happen when this is happening. This is what's called, I can't remember the name of it right now. Hang on, it's what's called closure. It's what's called a closure. Here's an example of a closure. Here's an example of what a closure does. Here's a really good example. So we've got the let now, right? We've got let test, and then we declared the function. And then if we came down here and we said test is equal to test3. Now, if we were able to run this, which I don't think we'll be able to run this right now, but if we were able to run this, what would happen is if we passed this as that, it would run the else logic there. Doesn't seem right, right? Doesn't seem right. It should seem that we changed test down here to test3, and then we called my function with test3, right? So one would think when you came up into here, since test is actually usable inside of the scope of the function, and it doesn't matter if you do, by the way, if you do const declared versus function declared, it works the same way in this case. So the fact that we have test in here and we change the value of test here to test3 and we pass test3, you would think that the call would get inside of here and would actually run this logic. No. When we declared this function, test was of the value test. So this created what's called a closure. What a closure is anything from outside the scope of the function. So anything inside of here that's declared inside of here is scoped within the function. So any changes within the function are done within, are kept within there, basically. But if you have something that is of one value, and then you declare a function while it is of that value, and then you change that value later on, the function will keep the original value. The function will still be inside of here. Test is still known, or it still has the value of test, not test3. Even though we changed the variable that got closed, got brought inside of here, that no longer is in here. It created its own copy of test when the function was created. So when the function was created, it created a copy of that variable from outside the scope and kept it internal. Now, if you do this on if you want to, you can utilize this to do things on purpose and use functions that way to purposely create closures to be able to do certain things with them. It can be an interesting thing when you know you're doing it. But when you don't know you're doing it, this can drive you absolutely insane. This can drive you insane because you're left going, why is it failing? My value is this and this and this. Why is it failing? And a lot of times it's closures. And you'll see closures even sometimes where there shouldn't be closures. So closures can, when they're meant to be done, they can be very useful. But a lot of times, more often than not, in my experience, they're a pain in the butt. They really are. So that's why I wanted to bring up this whole thing and all that, because I wanted to show that because it's declared outside of here, you can still use the value inside of here, but the value is the value of what it was up here because the function is declared here and then the value is changed. But a copy of that value was created inside of the function. So now the value is held at test even when the value of the variable itself is changed. That's closures. And that's a very important part of JavaScript. It's something that's actually probably a bit more advanced. That's probably not necessarily beginners, but it's something that even as beginners you'll run into and you'll wonder what's going on, and it will drive you absolutely nuts. It will not make sense unless you understand that. And you'll see things about it. It's spelled, if I remember right, Closure, I think is how they spell closure for that. I think that is the right way to spell closure anyways, but yeah, like I said, brain isn't 100% working right now. No questions. All right. We will keep going then. So we're getting close to time. Yeah, I don't know. Let's try to go through something of looping. So let's go ahead. For example, what we could do is now really quickly, we can put test 1, and now it'll actually test this test instead of testing the test from the outside. So these kind of things are all great. Functions are great. It's really great to the concept and the idea behind functions is to encapsulate a certain feature, something, to encapsulate something in something reusable. You want your function to do whatever it is you want it to do. You want it to do a very specific piece of thing, but you want that function, if you want that code to be callable over and over and over again and not have to duplicate that code all the time, then you put it in a function, and then that function is called all over the place. That's why you see things like common functions here. These are used all over the place. I've got a bunch of these that I use throughout the library, and I've just captured them inside of functions because I don't want to rewrite this stuff. I mean, look at this stuff. You really want to see this littered throughout your code base? No, of course not. Excuse me. So what do you do? Well, what do? You end up putting it inside a function and then calling it inside your code all over the place. And so then it gets recalled, reused, and all that kind of stuff. That's the advantage of function. Oh, stupid keyboard. That's the advantage of functions, and that's why we use them. We use them because of that very reason. So, but functions are great, and if you only had conditional logic inside of functions, it's not going to do a whole lot of good. Now, you don't have to do the next part inside of functions, but I've got a function here. I might as well use it. Probably one of the most important things, and one of the things you'll do a lot in software and you'll do a lot in coding, is you will do loops. And loops are working on pieces of data, pieces of data. So let's just declare, let's do const array is equal to 1, 2, 3, 4, 5. There we go. Yeah, fine. And so now we've got our array here. So we'll go ahead and we'll get rid of all of this. There are a number of different types of loops. The one you'll see me use almost exclusively is the for loop. I like the for loop. Technically in JavaScript, it's not the fastest loop. The while loop is supposedly the fastest loop, but I still like the for loop. There is one very important thing about looping, and I'd like to get this in today. There's one very important thing about looping in JavaScript that you must know, and it's different than other languages. Most languages, you loop from the beginning to the end. So from the 0 index on. That's another very important thing. Even though this is the number 1, this is actually at the 0 index. So if I said array 0, I would get 1 printed out. That's the example. So even though this goes to 5, technically this is index 4. So it's a 0-based indexing inside of JavaScript. Almost every C-like language, all C-like languages do 0-based indexing. Matter of fact, I think I posted not that long ago, the only language I can think of that doesn't use it is VB. It uses 1-based indexing. They had to be different. Anyways, so, but for the most part, you'll see that. Now, in JavaScript, the fastest way to loop through an array is to start at the end and subtract the beginning. Here, I will show you the absolute fastest for loop. This right here is like, this is things I try to get developers at my job to do. I try to bring it up to them. Now, there's reasons not to use this way. If the order of the looping is important, in other words, if you need to process the things from beginning to end, if that is a must, and it does happen, trust me, there's many times where I've had to give this one up and not use this one because it's going to cause a problem. But if it doesn't matter how fast, if it doesn't matter which order you process things, if you can process them in any order, you just have to process them in the quickest way possible. I'm going to do this in the for loop because it's going to look strange, and that's why I'm going to use it, because it's going to look strange. But this is the fastest way to loop in JavaScript. So we've got let I. Normally you'd say is equal to 0. You'd say let I is equal to array.length. I'm pretty sure about this. No. Not equal to 0, but boom. Okay, that's the fastest way to loop in JavaScript. It looks strange, I know, but this is the absolute fastest way to go through loop. Now, like I said, in the case of this, where we only have 5 items inside the array, it's not going to really matter. You could loop it the slowest way possible, and it's still going to be super fast. You're never even going to see it. But when you get to the point where you're getting into the tens of thousands of records, and it happens, trust me, it happens. You get into, 5, 6, 7,000 records, and I've got a component here that does that very thing. Things like this are very important. How does this work? Okay, it may look strange, but how does this work? So we start at the end of the array. So like I said, subtracting for some reason, subtracting this way is faster than adding. So it's faster to do minus minus than it is plus plus. I don't know who found this out. I don't know how. I just know that this is the way. Whenever you talk about JavaScript performance, this is like one of the biggest ones that comes out right here. Subtracting is faster than adding. And doing it this way for a for loop is the absolute fastest for loop you can write. Now, like I said, I've been told the while loop, you can do something similar for a while loop just like this. And I've been told that the while is actually a little bit faster. I don't like the while. It's just a personal preference thing, but you can use the while and you'll probably even get more performance out of it. How does this work? So we said at the end of the array, we say I minus minus is not equal to 0. Why do we do that? Well, I don't know how many of you know. I'm gonna go a little bit over today because I really think this is like a very important point to bring up, a very good beginner point to bring up. There are 2 ways to write an increment decrement operator. This is the decrement operator. I minus minus says take whatever's in I and subtract 1 and then reassign it back to the variable. However, this operates different than that. You can do both, but here's the difference. When you do this, what happens is the evaluation here, the not equals to 0, is done before the change of the value here. So that means the first time this is compared, this is I is equal to 5. So even though it does I minus minus, what happens is it says is 5 not equal to 0. And then after that thing goes ahead and approves and says yes, that's true, then I gets reassigned to 4. So when you're on the last item here, technically you'll say 1. It will be on 1. So what you'll do is, even though this will be reassigned to 0, what you will say is, it will say, is 1 not equal to 0? Oh, it is. So then it goes ahead and runs the very last one and then reassigns it to 0. Now, here's the fun part, though. The reassignment happens before it goes inside of the loop. So when you're inside, it will actually run the last item, or the first item in the array. So you'll still process every item in the array, but the evaluation happens at a different time. So the next time you come through, this will be 0. It will do the check that's not equal to 0. Technically, I do believe, I'm not sure if when it kicks out, if it actually does the reassignment or not. But it doesn't matter. Even if it does do the reassignment, it doesn't matter, because you're going to jump out and you're going to move on. This is the fastest way to do loops inside of JavaScript. Now, this is a JavaScript specific thing. TypeScript, in the things I'm talking about here, TypeScript and JavaScript are pretty much one and the same. The only difference is, in TypeScript, you can actually give it a type. That's really the most major difference. Of course, there are a lot more differences than that, but from a very basic level, that's pretty much the difference. So when I say TypeScript, when I say JavaScript, I'm kind of using them synonymously because they are pretty much the same. It's just that TypeScript provides the ability to do design time typing. That's going to have to do it. I was kind of hoping to make it right at 2:45, but we're going to have to end this here today. The space will be starting immediately after this. So hopefully you guys have seen the space that I posted. I'm going to be starting it up here on my phone right here. So I will be getting there quite literally right now. Oh, I don't have my AirPods. Oh, man, I got a lot of text messages. Okay, good. Yeah, that was all from I had a delivery earlier today.